एक मिनट हाँ
अरे हाँ तो मम्मी बुला रहे हैं बेटा आओ ना
बेटा के खाते में 500 रुपए है क्या? ये डाल उस दिन उस नंबर पे डाले थे ना उसमें डाल दे आप जानते नहीं तो मैं कहाँ जानती हूँ बात कर सकती हूँ और कुछ नहीं कर सकती मेरे वो व्हाट्सएप बंद हो गया इसमें वो नंबर है ना जेबीसी 2000 पे डाले थे इसके नंबर है वो तो क्या ध्यान देंगे इसको है ना वो नंबर भी है ना नंबर क्यों आप बोलो ना नंबर हाँ नंबर बोलो आप इसे वो तो नंबर निकाल तुझे याद होगा तो बोल ही बता दे पेंडिंग का तुझे याद आता है कितने रुपए भेजे थे 1000 रुपए भेजे थे ना आपने नंबर तो बताओ ध्यान रहेगा याद है क्या नंबर दे दो उस लड़के का नाम भी मैं पूछूं पहले उसका नाम क्या था तेरे उसमें नाम आ जाएगा ना नाम पूछती हूँ मेरा व्हाट्सएप चल रहा है ये थोड़ा उनके नाम है सोहेल लिखा हुआ है सोहेल 1000 रुपए भेजे थे वो मेरा के व्हाट्सएप पहुंचा पे दूसरा मोबाइल में सिम डाली है ना तो पे व्हाट्सएप में आवा को नहीं मेरा व्हाट्सएप पर नंबर भी या नाम नंबर बता दे है क्या भैया नंबर बताओ नंबर बता ले नंबर डाल ले आओ इधर आओ बेटा हाँ निकाल ले 76 फिर 7 76 10 650 46 408 8 आगे हाँ आगे ठीक है सोहेल खान लिखा हुआ है हाँ हाँ ठीक है हाँ 500 ये यहाँ पे है ना ये लो ये तो पैसे तो लेने तेरे वापस डलवा लेना तेरे इसमें तो मेरे दो क्योंकि साथ सही रहता है ना हाथों हाथ वाला हाँ और नहीं अच्छा आज खत्म हो गया जा बेटा मैं हाँ प्यारी हो जाओ हाँ नहीं रोज हमसे बात करना बताओ तो ना ना उसका कोई दुकान खोल छोटा मोटा टाइम पास कर रहा है
कोई सोयाबीन का तेल अगर लेने आएगा तो देने का 80 रुपए में बोतल। About that, I didn't think that was officially her age, but you probably right. Oh, that was the cop who was training with the bull. The other guy that was the one who was telling him. Remember, he called him and said, "Oh, yeah." Because the guy came to his office and that guy came to his office. Oh. Oh, what the? Wow. I don't know if he's really there, but I guess I'm saying that that girl is gonna be his future. Okay. Yeah. It's either that or he's married and just trying to have a mistress. Yeah. It's one of the two, but I'm sure he told him that.
So let us
This
start with
conference will now be recorded.
yesterday's session. We were discussing about data types. So before that, let's do a quick revision. So what all things we have discussed yesterday? Sorry, first we discussed about arrays, string basics, literals. Okay. Talking about arrays, we understood that arrays is basically two types: static and dynamic. Static, fixed size, how to do the declaration. In dynamic, there are three types. One is dynamic, associative, then queue. So as we go forward, we'll understand that dynamic array has methods like new, delete, and what is the size? That's all. The size are num. Will be num. Only these three methods are there. Other than that, you can also do, of course, a reverse shuffle. These are the methods. You don't need new. Push back, push front, pop back, pop front, insert. These all methods. Associative array we will see. I mean, the first, next, last. There are some methods which I'll introduce when we go to the associative array topics. So in yesterday's session, while talking about arrays, we understood how to declare arrays, how to initialize. When you want to fill some values, how do you do that? How to compare, copy arrays, all those things we have understood. And also, while talking about string, we discussed some concept of how to declare a string. We also discussed the significance of $s format f, $s format, and $ps printer. If you see, all of them are same actually. Small difference in the way we use, but they does same thing. Do you remember these concepts that we discussed yesterday? Okay. String is dynamic in system Verilog. Tell me what is meant by dynamic here. Size can be increased, decreased. In Verilog, it is fixed. If you have given 20 into 8 down to 1, it will only hold 20 characters. You cannot be more than that. Whereas in system Verilog, you can give any size, it will automatically resize the string. So again, I'm telling this is not like we have completed this. We'll be going through all these topics again, just a revision, okay? And we have discussed about literals. What all types of literals did we discuss? Integer literals, real literal, time literal, array literal, string literal, what else? Multi-dimensional array. So all these things we have. Then we were discussing about data types. We divided data types into two categories. One is the basic ones, integer based, void, and string. In the later part of the training, we'll be discussing about the other types of data types. So we started off with understanding integer based data types. So what are the classification we did? What were the factors based on we classified the data types? One is the size. One is sign or states. Is it from Verilog or added in SV? So I hope you all understand this thing. Anything you want me to explain here again? We have gone through these examples. Let me ask you one question. What is the range of? Please tell me what is your question regarding logic? Logic type? Yeah. Where do we use? It is basically how we use it is. Reg is used in the modules for this thing, behavioral kind of coding, right? For discretely driven elements. In system verilog code, wherever you need 4 state variables, which is not a design inside a class, we use the logic. Inside the module, we use reg. In the classes, we use logic. One of the questions, byte, what is the range? Tell me. Minus is the range. How can I write in another manner? 2 to the power of 7 minus 2 to the power of 7 to 2 to the power of 7 minus 1. Whatever is the size in the power minus 1 of that. Now, if I tell you in the same manner, int, what is the range? Tell in the 2 to the power manner. Minus 2 power 31. You take 7 here. 2 to the power of 31 minus 1. Short int. 16. What if I write bit 7 down to 0a? What is the range? Is it same? Is it same? It will be 0 to 255. Why? Because bit is unsigned by default. Unsigned means what? It's always for positive number by default. It's always positive number. Whatever you store, it stores it as a positive number. Oh, sorry, 15. I write signed here. What is the range? Minus 2 to the power of 7 to 2 to the power of 7 minus 1. So because now once you do this, this is same as a byte. In every respect, it's same as a byte because you declare it as a bit signed 7 down. You understood, right? How to come up with the ranges. So when you know that you have a variable which will only be between minus 128 to 127, okay, in your programming. So then you can declare it as a byte. You don't need to use short int, you don't need to use int or long int. Now let's talk about the next data type, void. Void is the data type used to refer to places where we don't want to use any data type. I mean, wherever you don't want to refer to any data type, there you indicate it as a void. I'll give you one example. For example, it is used for a function with no return data. If I have a function void print, because it is void, I mean, you don't want to return, this function does not return any value. So because of that, use void as a return type. So in this case, no need of return statement. So we don't want to return anything from a function. In those cases, since you want to tell that this function doesn't return any data, you declare it as a void. It could be, this is mostly the frequently where it is used. Okay. For example, are you familiar with the assert keyword? I'll explain. What is assert is like, it's like a if condition. If I write assert A equal to B, if it is true, assert is like if condition. It checks if A equal to B is matching. If matching, assertion passes. Else, assertion will fail. So assert will do like what? If condition. Only thing is, you may say, then why don't we write if condition itself? Instead of writing assert, why don't we write if condition? The advantage with assert is you don't have to print the dollar display. You don't have to write dollar display. If whenever it fails, it will tell you that this line number has failed. I'll show you through one example now. I have a module top. In module, I have declared two integers, int a comma b, initial, begin, end. I can just write, let's say a equal to 10, b equal to 20. Assert a equal to b. Tell me now, will it pass or will it fail? It will fail because a does not match b. So you don't have to write any statement. You don't have to write any display statement. It will automatically tell you that the assertion failed at this line. It says that assertion error, line number 7. On line number 7, you can see there is a assertion error. In case of using if condition, you have to write a display statement. If it is if condition, what you have to do? You have to write if a equal to b. Can I leave it like this? Can you leave it like this? No. You have to write dollar display past. Else dollar display. Something like that you have to do. See, both are doing the same thing. Assert makes it easy. You don't have to display. You say it's failed. In case of assert, you don't have to write that long statement. You can just write the statement. You can also write a statement if you want. So there's a possibility where you can write else $var. Assert failed. Now you can comment it out. So even in assert, if you leave without any message, it will print default message saying that, see, in the first case, I didn't give any message. It printed saying that assertion failed on line number 7. In the second case, we are giving a warning where we are telling that assertion has failed. So now if I run it, this assertion, whatever message you printed, it gave you that. Please go through it once. So assert is like a if condition. Okay, as I said, it is not just for this one. You can use anywhere. Let's say if I write, for example, assert 0. Tell me what will happen when I say assert 0? Nothing will happen, or what will happen? It will fail. Because 0 means logically false. So what it checks is, assert checks is inside the bracket. Inside the bracket, is it logically true or logically false? -1, tell me. False or true? -1 is true. Anything non-zero is logically true. 0 is logically false. Understand? Minus any number other than 0 is logically true, whereas 0 is logically false. So in this case, line number 12 will fail, line number 13 will pass. Don't think that assert is only for A equal to B. It can be used for anything. It's like you are checking some expression. Is it logically true? Logically false. See, line number 12 has failed. That is which one? This one has failed. This one has passed. When it passes, it doesn't show anything. If you want to display, you can write like this: $display. Logically true. You can also write else. Logically false. Now it will show you logically true message. So what I'm showing you is the different ways of writing assert statement. One is what? You don't write any message at all. Just assert. It will give you that assertion failure has happened. Now do you see logically true? Even when you write that $displays, you can write one of them, you can skip other one. All that possibilities are. So there are times where you want to ignore. I mean, whether it matches or mismatches, you want to ignore. In that case, you can just write void A equal to B. So whatever is the output, it is being static casted to void. You're ignoring that. Mostly we don't use this kind of thing. I mean, this is not useful. This is what is the use case. Having said that, it's not a very important data type. Only thing you need to know that in a function, when you don't want to return anything, you declare it as void. In fact, what I have noticed is even if you don't write anything also, it will treat it as void only. Just write function print without void also, it works. Module top. Yeah, here we are just displaying, so we don't have anything to return. Now we'll go to the next data type, that is string data type. Yesterday I have given you a very basic overview of what is string data type. String is a variable sized, dynamically allocated array of bytes. Bytes means what? Each character is a byte, right? Each character is a byte in ASCII. While storing in memory, all characters of string are converted into byte values. Every character is stored as an equivalent byte. That is the ASCII convention. 1 byte used for each character. String size can be increased, decreased, can be deleted at runtime. That is why it is a dynamic data. String resizing happens automatically. No need to use new. See, generally in C++, when you want to allocate a memory to dynamic data type, you use the concept of new. Even in dynamic array we discussed yesterday, how did we do? Array equal to new of 10. In the square brackets, we put 10. String is a special case where you don't need to use new. Means, what do I mean by that is, when I declare a string, no need to write new. No need. There's no need to do new. You can directly assign name equal to anything, let's say Verilog. It will automatically take 7 characters. Okay. Now if I resize it, again for resizing, I don't need to do new. Let's say if I write system Verilog. The 7 characters allocation becomes 30 character allocation. In this process, there is no need to do declaration, string, whatever you want to declare. This is a wrong declaration. String str2 in the double quotes is a wrong declaration. Wrong. Only to assign values we should use double quote. To declare you should not use double quote. String comes with various methods. Let's understand what are the methods string comes with. All string methods are functions. Every method in the string is a function. Let's go through some of those methods. Len is a one method. What do you think len should do? Tell me. Number of characters, right? Length of the string. So if you call length, tell me how will you use the length? I have a string name. I want to use the length. How will I use length? Let's say I declared count. I want to get the length into count. How will you get it? Count equal to name dot length. Correct, right? That's something. Returns the number of characters in the string. Put C. What do you think put C will do? To put a character. Put character, right? Put character. Now, where do you put the character? Anywhere. So tell me, if that is the case, how many arguments are required? How many arguments are required? You want to call a put C. So how many arguments will be required for put C? 2, right? One is where you want to put, in which position you want to put. One is the position. And the second is what? The character that we want to put. Let's say Verilog is there. Verilog is the string value. I want to put after R. X I want to put. So what will I do to convert this to this one? So name dot C. Here you need to understand the order. I mean, which one will come first? Whether the number should come, that I need to check. Put a character into the string at specific index. Passed as put C argument. Index starts from the left hand side. So index starts from here. So third index. Let's try this once. What is it doing is it is actually replacing it. It is not inserting, it is replacing. So I is being replaced with X. Now we can check whether there is a method by name insert. Okay. Though we are going through all these methods, see, put character, get character, to upper, to lower. Many times we don't use them at all. I mean, this is a string is a kind of data type which we don't use Means we don't see, where do you really find put C, get C useful? Mostly in the programming kind of softwares, right? Because software is where a lot of string processing happens. Why? What is meant by string processing? You go to a hotel, they will take your billing, what is the item you have purchased. So there the strings come into picture. In verification, in test benches, you don't deal with strings much. You understand the difference, right? In a programming kind of requirement, you have to deal with lot of strings, names and strings. In test bench, there won't be any strings, there won't be any names. Mostly it's not, we don't have to use all this thing much, to upper, to lower, get C, all that. But just to understand, get C will do what? Get a character from string at specified index passed as get C argument. So let's try this. If I call string char, let's get C, char equal to name dot get C, let's say 2, I will get from 2. So I should get E. Let's display. You no need to initialize. No, you're getting from the name, you're getting a character at position number 2. You already have name. From that, what is the variable at the position number 2? You're getting into character. So you print char once, you print name. What is the problem here? Assigning packet type byte to a string requires a cast. This should be byte cache. When you get a character, you are getting this one. What do you say? A byte, right? One character is a byte. So each character is like declared. Whatever character you get, you should declare it as a byte. So that character you get, what is that you are getting? The second, right? 0th index, first index, second index. So you're getting R. Get doesn't remove the character. Get character will still be there. That character will still be there. So we can just do one small change. Put a character into the string. Replace a character. Replaces a character in the string at specified index. Whatever you pass as part of the put C argument, it replaces. But again, I'll repeat, these methods are not very important. I mean, you understand them, that's good enough. Okay. Because probably it may so happen that next 10-15 years, you will never use put C, get C, all those things. Sometimes maybe to lower, to upper. What do you think to lower will do? Convert all characters in string to uppercase. To upper will do what? Convert all characters in string to uppercase. See, because why? What is the point is, in a test bench, do you really have to do all this manipulation of string? No. Let's say you are working with SPI controller. Does SPI controller requires any kind of string manipulation? Does memory requires any kind of string manipulation? The same thing here. Unless you have a kind of a project where you have to work with strings specifically, you don't need these methods. You don't need to really work. But just remember that string comes with these methods. So I will not really spend a lot of time here. Okay. Substring. What substring will do is, you can choose out of specific characters. You want only character number 2 to 5, let's say. What is 2? R. I-L-O-G. So R-I-L-O will come. When you take a substring, you have to tell from which position to which position. So it will take that slice. So get a substring of characters as specified between 2 indices. A lower index must be the first argument. If you pass this way, it doesn't work. See, you cannot take from 10 to 3. You have to take from 3 to 10. First number should be the lower one. Next number should be the upper one. So let's quickly revise. So what all methods, what all things are there? Length, put C, get C. What else? Two upper, two lower, substring. Not only that, there are some more methods are there. Let's quickly read through those methods also. Compare is one method. It is used to compare two strings. Then we have another method by name I compare. It is used for comparing two strings. I ignore. I means what? Ignore the case. Means ignore upper and lower case during the compare. Compare and I compare returns int as an output, not a bit. Generally, what would be your understanding? What do you think compare should return? I will take one example. Name one, name two. Okay. Let's say I have int value. We'll write value equal to, how to use this? Name one dot compare, because compare is a method of a string. So string name dot compare. In the brackets, I'll pass what? Name. Tell me if I display value, what should be printed? So here, right, string. Getting the point? How many strings did I declare? Two strings. Name one, name two. Name one equal to what? Very long. Name two equal to what? HDL. Then in the line number 8, what am I doing? I'm comparing. Name one dot compare, name two. So when I compare, what should be the output? If they don't match, 0. So that is our understanding. But when it comes to strings in SystemVerla, it's not like that. It is not 1 and 0. It returns an integer which tells V and V have compared, but E and H have missed, right? What is the position of E? 5. In alphabetical, what is the position of E? 5. What is the position of H? E, F, G, H. 8. So it will give you 3 or something. Let's check that. I'll just because it returns the integer, I'll print B also. So that whichever is the correct one, we'll take. So whenever mismatch happens, it gave me 3. Why it gave me 3? Because the first mismatch that happened, they were differed by 3 characters. If it just gives 0 and 1, you don't get that idea. It gives this number also, where it will tell how many alphabets they are missing there. Same thing if I take instead of G, I have taken A. How much do they differ by? 7, right? They differ by 7. So maybe they will give -7 now, because difference is in the other direction, right? You got it? 6. Do they really differ by 6? B, C, D, E, B, C, D, E, F, G, H. It should have been 7. G, okay, G, right? Okay, yeah. So it should be 6. Okay, so it doesn't give anything like -6. It gives only 6. In either direction, it gives the magnitude. It doesn't give the negative or positive. Okay, it tells you wherever mismatch happens. Somewhere mismatches differ by 6 positions. You got the idea, right? Now the question comes: what if they match? Tell me, if they match? What do you think is the output? 0, right? So it's a reverse. If they match, it returns 0, saying that all characters match. There was no difference in any alphabetical positions. So if I run, what should be the output? Give me 0. So tell me, should I print it as binary or decimal? Decimal, right? Because I want to know the position. So decimal will give me the correct representation. Now I'll get 0 value. Value is 0. I compare also does the same thing. Only difference is I compare ignores the case also. In this case, if I go and run this case, tell me, what is the output? Tell me, will it be 0 or will it be something? It won't be 0 for sure because lowercase v, uppercase v. So they will definitely differ, right? I'm not using I compare. So when I call just the plain compare method, it will compare case to case also. Is it lowercase v? No, right? So it will give error. 32 positions. Now, how it came up with 32, we need to see. Yeah, maybe after we need to see how that 32 came exactly. Okay. But if I use I compare, it will give 0. So it looks like difference between lowercase and uppercase will be 32. Compare starts from the leftmost character in the string. If their comparison mismatch, ASCII value difference is the output. If first leftmost character matches, then go to the next character. Wherever mismatch happens, it exits. It doesn't compare the remaining things. Mismatch happens, so no need to compare. Only drawback is it doesn't tell the position of the mismatch. You have to go by that. That's fine, that you can always see. Okay. Then there is two methods called as A to real, I to A. These could be two important things. What is A to real is, A means ASCII, real. It is used to convert ASCII to real format. There is one more method called as I to A, which is used to convert integer to ASCII format. Let's quickly talk about it. ASCII character means .sv only. Let's say I take real r equal to name dot a to real. Let's display r equal to what? Percentage f r. Keep it string. So it is giving 0. No, not that. Actually, that is not the thing here. Name equal to 3.1415. Let's see. If I give a number, it converts. See, right now number is in what format? Number is in, sorry, not number. Name is in string format. Holding a number. Holding a number internally. Internally, it's a number. But if you ask me, is it a number? A string, because it's put between double quotes. That number, that string, you want to get it as an equivalent number. Got it? You don't want it to be treated as a string. You want it to be converted as an equivalent floating point, real number. So that is where A to real can be used. That's gives you 3.1415. That means what? I'll give you the best example for this. Is that the use case? We are reading a text file. Okay. and other file handling system functions. See, we are reading a text file using $fopen. Text file has some numbers. Let's say text file has what? Some numbers. If we are using file handle, we get number as ASCII character, not as an integer. Mean, whenever you read the file and you read from the file, there is a method called as get. If you refer to the Verilog file handling methods, there is a method called as get $f get or some method is there. Using that, you can get what is there in the line. I'll show you through this. Let's say data in dot text. It has got some numbers. The name of the file? Data in dot text. In Verilog, there is a provision where file handle equal to $fopen data in dot text. What this command will do, line number 86, whatever we have done, it opens the file and keeps the handle in fh. What this will do, it opens the file and keeps the handle where? fh. Now using fh stands for what? File handle. When you start reading, you start getting this one by one. This will not come as a number to you. It will come as what? String, ASCII character. It will come as an ASCII character, which is a string. So once you get it as a string, you don't want it to be string, right? You want to treat it as a number. You want to see it as a 32.32.32. That is how you want to see. That is where you can use whatever element you have read, dot A to real. So when you get the value, that will be a real number. So declare the value as int if you want to read it as a integer. Declare value as a real if you want to read it as a real number. Can you do this homework? What is the homework I want you to do is the same activity. You create one file like this. You create a file like this with some numbers, some real and some floating point, real and integer numbers. You should develop a simple Verilog code. Okay. What it will do is, it will open the file. It will read all of them. It will do the addition and print the value. Let me give it here. What is the activity I want you to do? Take a file which has 10 lines, each line having real or integer number. How many numbers are there in the file? 10 numbers are there. Okay. It's like simple example. Imagine take a file with, let it be 30 lines, each line having real number. That number represents temperature of the 30 days temperatures. It's a Bangalore a month has 30 days. In this file, someone has captured what is the temperature for day 1, day 2, day 3, 30 lines. Numbers represent temperature values. A month. Now, what I want you to do is, you should develop a Verilog code which will develop Verilog code or system Verilog code in this case, to open the file, read the contents, get the average value. Average, get the maximum temperature, minimum temperature in a month, the month during this month. You got it right, what you have to do. You have to create a file. So I'm not going to give you files. You took randomly 35.2, 24.7, 28.9, like that. You take some 30 numbers. So when you read it, it won't come as a real number. You cannot do direct addition. There you have to do this. Whatever element you read, you have to convert to A to real. That is how we use A to real. What is I to A will do? When you have an integer, it converts to ASCII. That's you have, it does the reverse actually. You have 3.14, which is a number, or 34 is a number. You want to convert it, treat it as a string, then you take this. Fine, right? Okay. I think we have tried other examples also. More importantly, try A to real. That will be good. Okay. So these kind of things can happen. I mean, this is a possibility in actual verification where your design is processing some inputs, okay, which is coming as a text file. So you are reading that file, processing that information. So that could be a use case scenario in the actual projects. I think I have told you how to get the length, okay, output character, all that. And here I have just written some examples. I'm purposefully skipping them, not going through in depth, because I said that these are not very important. I mean, what is the question? Whatever question I have given is, you can try it because it will give you a good exposure to how to work with files in Verilog, how to read the information, how to process that information. Next, let's go to the next part of the string topic, that is string concatenation. Technically, if you see, string is nothing but a vector. In Verilog also it was a vector. Even here it is a vector. How do you do vector concatenation? How is vector concatenation done? Using flower brackets, right? Same thing here. To do string concatenation, let's say I have string name1, name2, name3. String is like a bit vector. It can be used in concatenation. So name1 equal to name2, comma name3. When I concatenate, let's say I follow this convention. I have name3. Name3 equal to, how do you do concatenation? Name1. So do I put the double quotes here? But then, no, right? Name2. Okay. If I give two additional spaces here, can you tell me what will be printed for name3? I gave two additional spaces here. What will be printed for name3? Can you please write it in your notes? You got it right, what I said? I have given two additional spaces. What will be printed? Tell me what will come. Will there be any spaces? No spaces. It ignores. See, during the compilation, tool ignores this. So it will come without any space. This comes continuously without any space. Verilog, VHDL. What if I wanted one space? You have to add one more string actually, which is a space. How to write a one more space? Let's say I want to print as like this. Verilog space VHDL. Tell me, what should I write? Okay. So what should I do? One space like this. These spaces don't matter. Whether you keep it like this, whether you give, but this matters. If you give as many spaces, those many spaces will come. Now if I run, it come with one space. What if I wanted VHDL to be printed in the next line? What should I do? If I want VHDL to be printed, I think in Verilog you'd have studied, right? You have to write what? \n. All those concepts, what you studied there applies here also. VHDL will, I didn't do display. In this case, VHDL is coming in the next line. So name 3, as I said, name 3 will be printed in the next line. Here we have just done few examples. You can go through them. Print complex diagram. See, you can print a complex diagram like this. If I just take this, here I'm using \t means what? Tab space. 2 backslashes means what? Means printing only one backslash. If I use multiple backslashes, two backslashes will be treated as one backslash. Whenever I want to print one backslash, I have to use 2 backslashes. I want to print a forward slash means I have to write backslash followed by forward slash. These are all called as what? Special characters. These are all called as what? Special characters. Let's understand some of the special characters. How to give tab space? \t. How to print a forward slash? \/ followed by forward slash. How to print a backward slash? 2 backward slashes. How to print percentage? 2 percentages you have to. You have to print 2 percentages. Let's try that also once. I wanted to, in between, I want to keep a percentage. Run it. Should give me Verilog percentage. Okay, 2 percentages giving. Okay. Here it works. Maybe in the dollar display, we have to take care. See, dollar display percentage has a special meaning, right? What is special meaning? It treats it as a value. Percentage D means it treats it as a value. So there it is there. Here you can use directly. So if I run this example, gives me some kind of portal. Then where do you come across this kind of things? If you go to Qualcomm, when they print the results, they'll try to give this kind of special processing in the beginning. When they give the data, first they give, then they print all the information. So this is how you can print special characters and all kind of thing. I mean, the way you want, whatever shape you want, you can get by using these special characters. What special characters we used in this whole thing? Tab, backslash. Only we used two things, and other than this, we used hash. Hash is not a special character. So using only those things, we are able to get this kind of shape print. For example, I wanted this to be a forward slash. So this alone to be forward slash. Just figure out where does it come. Here it comes, right? Take this one alone. That alone comes as a forward slash. Like that, you will be able to get the required. Again, for your learning, for the training purpose and all that job purpose, do you need to learn all these things? Not required. You can just remember what is meant by special characters, all those things. How did we use backslash t? Is 2 backslashes. Why did we use? We wanted this thing to be shifted by 2 tab spaces more. Compared to this line, this should be shifted by how many tab spaces? 2 tab spaces. Because of that, we use 2 backslashes, 2 tab spaces for this entire rows. So this is about string. String $s format f. So let's discuss. You know, right? Yesterday we have discussed about $s format f. Why do we use $s format? $s format f is used to create variable named strings. Variable named string based on the index value. We have a requirement to give names to each environment. As the number of environment changes, it is difficult to keep adding and deleting lines. So like this, we want to give one name as env0, other name as env1, other name as env2. As the environment, based on the environment number, we want to give the name. So SV provides $s format f or s format, which can create dynamic string based on the index. $s format used as a task, $s format f is used as a function. So yesterday we have understood, right, how to use it. $s format in the name in the brackets itself. env %0d. So %0d will be replaced with value of I. That entire string is assigned to name. So whatever is the value of name, that will be taken. This is useful when we create an array of components and need to give specific needs to them, specific names to them, names varying based on the index value. This is that example. Today we have tried already this thing, right? You remember? We are giving a different names. You can refer to this example. This concept is important. $s format f is important because during our test bench development, we want to give different names, name 0, name 1, name 2. So which is based on the index. To get that, we use name %0d. That %0d replaced with I. That whole thing going into $s format. So the last topic in string is string reversal. Let's work on it. See, for a queue, there is a method for reversing purpose. There is you can reverse the queue just by calling queue.reverse. How about reversing a string? Say I want to string reverse.sv. Module top in module string name equal to, let's say, Verilog. I want to reverse. Can I call name.reverse? Is it fine? It is not possible because why it's not possible? There is no method by name reverse. String does not have a method by name reverse, hence it is not possible. If it was a queue, it is possible because queue has a reverse method, but string doesn't have a reverse method. So then how will we reverse if we don't have it? You have to go through the for loop. You have to go through the long process. You have to implement your own algorithm. Since the tool does not give you any method, you have to implement your own code. So let's do that. So what is the best way to do about it? So write a for loop. Int I equal to 0, I less than what? Name.len. Name.len will give you the number of characters, right? I plus plus begin end. What should I do? Name one. First thing you do is name one equal to name. You do this. Can you think what should be done here? Want you to come up with the logic. It's very easy. You just have to reverse the characters. Please try this. Name one equal to name. Then name one dot put C, put character. First, what you have to put? The character, right? That is how we used, right? Isn't it? What's the number? Position. Position is I. What will I put? Name dot get C name dot len minus I. I think little complex, but let's call it as length equal to name dot len. You will easily understand.
I has name dot.
Length. Here use len minus I. 1 second. I'll tell you. I will do it and then explain you what is this means. Dollar display. Len is undefined. Okay, everything is there. V is not getting. V is not going. Let's just check that part. -1. Probably the problem with the, now it's fine. See, very log in the reverse direction, right? So what are we doing here is, let's understand the algorithm. First, we are actually speaking, this was not required. You could have used, wherever len is there, you could have used this one only. But why I didn't use is, it will complicate your understanding. The expressions will get more complex. So I used variable by name len. First, what am I doing? For loop. Going through the each character. I'm going through each line, each character. I equal to 0 to I less than len, I equal to I plus 1. Name 1. What is name 1? It is right now Verilog only. Name 1 as of now is what? What am I doing is I'm telling put character. Put character, does it insert or does it replace? Replace. So we want to replace. So what I want to replace? I want to replace V with G. So how do I get G? Get character. Len minus 1. What will be the len? 7. 7 minus 1 is what? 6. Right now I is what? 0. 6 minus 0 is what? 6. What is the, which character is at 6th index? G. So G will replace V. G will replace the V. When I equal to 1, who will replace whom? Tell me. O will replace E. Why? Because len minus 1 is always fixed. What is that? 6. 6 minus 1 is what? 5. What is there at 5? O. O will replace the position at 1. Then what about L? R. I will replace I. R will replace L. E will replace O. V will replace G. That is how you get the reverse. Understood? Please go through this code again. I'll ask you to develop the same code. Understood? Can you develop this code again in your notes? See, why we are learning these things is not because we'll be using string. You probably won't use string much, but these are the algorithmic skills you should develop. Simple algorithmic skills, how to work with a for loop, how to do the reversal of something. These kind of skills I want you to develop. Not that you will be working with strings. Most probably you won't use strings at all. Very less you will use. But this is algorithmic skills, nothing to do with string at all actually. Please write the logic. So you can check again once. Okay. First, what are you doing? Name, you have given the value. Why are we doing this? 7. If you don't do it, it won't work. Because name 1 should be initialized. See, what putC does is, it doesn't put an element, it replaces the element. It replaces. If it is empty, let's say you don't do this line, what will be name 1? It will be empty. No characters will be there. If nothing is there, putC will not work. If nothing is there, put character will not replace at all. So hence, purposefully, we are initializing name 1 equal to name. Whatever is the name, Verilog, we are replacing the same name. We are putting same name. Then we are going through a for loop. which is going through the length iterations, and name one dot, put character. In which position? I position. I will start from 0, 1, 2 up to 6. You place there. Now, whatever be the size, let's say if it is system Verilog, will it work now? Will this work? It will work, right? Because my code is not hard coded. My code don't have any fixed numbers. It works on the variables. So even if I use this, it will work. Okay. So this is about how to work with the strings. Let us take a short break. We'll meet in
This
10
conference
minutes.
is no longer being recorded.
We'll meet in 10 minutes and we'll continue. I mean, I could do arrays, but I mean, I want to give break so that you can just come little. 10 minutes and we'll continue. So you have any doubts related to string, please ask me after the session. After the break, please ask me. I don't want to hurry through the arrays and other things. If you want me to revise any topics in strings, let's say you didn't understood put character, get character, compare, any of those things, please ask after the break.
This conference will now be recorded.
Okay, let's start with the revision of string. So in string, what all methods did we discuss? Len, C, get C to lower, to upper, substring, what else? A to real, I to real, compare, I compare. These all methods discussed. So you can try to practice some of these methods. More importantly, whatever assignment I have given A to real, that you do it. Okay. Then we also discussed reversal concept manually implemented. Anything you want me to explain related to string? So now let us move to the next topic, arrays. We have discussed arrays a little bit yesterday. This is not going to be any different. It's the same concept. We are going to discuss each and every method now. So you go to dynamic array. What is meant by num? What is meant by new? What is meant by delete? Like that, each and everything we will understand through examples. What is an array? Homogeneous collection of elements. Homogeneous means what? Same data type variables. Mailbox is not homogeneous. In a mailbox, I mean, going forward, we will use a data type called as mailbox. You can put different types of elements into mailbox. You can put an integer, you can put a string, you can put a byte. There won't be any restriction. Whereas in array, everything has to be of same data type. Next thing is arrays are non-singular. See, what is meant by singular is integer A is a singular because it represents only one value. Byte B is singular. Whereas int array of 4 down to 0, how many values it represents? 5 values. Hence it is called as non-singular. Whereas int A is what? Singular, since it represents only one value. Why arrays are important? I mean, as a verification engineer, arrays are important for us. Strings are not important. Like I said, when we discussed string, I said it's not important because it's important from a program software developer perspective, not from a VLSI engineer perspective. But when it comes to arrays, it is important. One is because it is easy to handle multiple data variables as a single entity rather than as multiple entries. What does it mean? Instead of declaring int A0, A1, A2, A3, A4, instead of declaring 5 different variables, it would be more easy to declare it as int array of 4 down to 0, where one element representing five integers. We can access individual elements using index. We can write int A of I. So instead of declaring them as 5 different variables, it's more easy to represent it as a one array of 5 variables. Next, array can't be assigned a value as a whole. Int A equal to 10 is not possible. You have to access by index only. Always access array elements by index. Now, continuation to this why arrays are important, let's talk. Every program involves, every code we develop will require to use anything you develop, it will require us to use arrays. Okay, that is one thing why it's important. This is a different topic. I mean, array can't be accessed as a whole is not related to arrays importance. It is important for 2 reasons. Every code you need arrays, and it makes it easy to handle multiple data variables as a single entity rather than as multiple different entries. Okay. Next. Array classification. Array can be classified in 2 ways. One is classification based on how the memory is allocated. Second is classification based on when the memory is allocated. One is how, one is when. So first let's talk about how scenario. So first let's talk about array classification based on how the memory is allocated. There are two types of arrays in that. One is called as packed array or one is called as unpacked array. The packed array is same as vector in Verilog. In packed array, memory is allocated in single address location for complete array. For entire array, the memory is allocated only in the one single address. You know, right? Vector, how vector gets stored? The vector gets stored in one single location. That is the single address location we are talking about. The dimensions of array declared before the array name. For a packed array, dimensions are declared like this. So this is the name of the array. What is the name of array here? A. So the dimension 3 down to 0 is declared before A. Data type can only be bit, reg, or logic. You know, right? It's all same as in Verilog. In Verilog also, vector can only have data types of reg or logic, reg or wire. Is this possible? Tell me. Int 3 down to 0 A. Is it possible? It is not possible. It is not possible to store 4 integers in the same address location. It's like storing 4 integers in the same address location, which is not possible. Analogy is like what? Making 4 people sit in the same chair, which is not possible. Is this possible? Byte 3 down to 0B. It is not possible. Why it's not possible is simple. Going by this, for a packed array, data type must always be bit, reg, or logic. This is not possible. Is it possible? Bit 3 down to 0C is possible. Why? Because the data type is bit, hence it is possible. Other guidelines are the same as vector guidelines. How to work with vector, how to work with packed array is same as the vector guidelines in Verilog. Next, let's talk about unpacked array. This is called as array in Verilog. Memory is allocated in multiple address locations. Number of locations is the size of the array. Each location size is array data type size. Let's understand. Number of locations is the size of array. Each location size is array data type size. Dimensions of array declared after the array name. For example, logic A 3 down to 0. It is an array, unpacked array, because why? Declared dimensions after the name of the array. Is it packed or unpacked array? Even this one is unpacked. Whatever you see here is an unpacked array because the dimensions are after the name. Here, what is the name of this array? A. What is the name of this array? A. Name of this array? B. When it comes to unpacked array, there are no restrictions on the data type. We can use any system Verilog data type. Like we use logic, int, byte. You can use any data type. Whereas when it comes to packed array, data type has to be bit, reg, or logical. This is the first classification. How array classification based on how memory is allocated. The next one is classification based on when the memory is allocated. What is that one? Two types of classification is there. One is static array, one is dynamic array. So let's now talk about static array, also called as fixed size array. In fixed size array, memory is allocated at compile time. Size is fixed throughout the simulation. In a fixed array, it is fixed. You cannot increase, you cannot decrease, you cannot delete. Memory size can't be decreased, increased, or deleted. Need to be declared with fixed integer number for array size and declaration. This is how you declare. Now can be both packed or unpacked array. It could be both packed, unpacked, and it could also be multi-dimensional array. User has to take worst case possibility into consideration when declaring the size of the array. When you are declaring the size of array, you have to take the worst case possibility that we have already yesterday explained, right? What is the concept of static array? Now let us talk about dynamic array. As we have discussed yesterday, dynamic array. In dynamic array, memory is not allocated at compile time. Memory is allocated at the runtime using new. It's the same statements. New and associative array exceptions which don't require new. These are the exceptions. Only for dynamic array you have to do new. For associative array and queue, you don't need to do new. Without doing new, you can directly use. It's similar to string. In string, did we do new? No, right? Without doing new, we are able to use them. Same way, queue and associative array can be used without even doing new. Next, dynamic array also can work without new by doing array assign. I will explain this concept. Okay, here, this is an example where you can work with dynamic array without using new. Please take a look. You're declaring a dynamic array, int DA, open bracket, close bracket, without anything. It is indicating that it's a dynamic array. You're assigning that equal to 1, 2, 3, 4. What is this called as? Array literals. This is the array literals. In this case, no need to use new. Even if you don't do new, automatically it will take size of 4. Because while initializing, tool understands that user wants to assign 4 elements. So I will size myself as a 4 size of dynamic array. Next, size cannot be increased. Size can be increased. Size of array can be increased, decreased, or deleted at runtime. And size is not declared as part of the array declaration. That is the specialty of dynamic array, right? Dynamic arrays can be unpacked type only. Can only be unpacked. That means this is not possible. See, why it's not possible? We are keeping the dynamic nature in the packed dimension, which is not possible. What about this one? It is possible because we are keeping it in the unpacked side. See, keeping towards this side is making it packed. Keeping it this side, the brackets, is keeping it, making it unpacked. So the second one is possible. Whatever you see in the red color is not possible. What about third one? It is also not possible. So next thing, we can also have multi-dimensional dynamic array also. Even we can declare multi-dimensional dynamic array also. It is also possible. Next. So till now what we have done is we have discussed arrays and the type classification of arrays. First classification is based on how the memory is allocated. What are those two classifications? Packed arrays and unpacked arrays. Second is what? Array classification based on when the memory is allocated. They are static arrays, dynamic arrays. So now let us talk about packed and unpacked arrays. Now let's talk about packed and unpacked arrays. So first talking about packed arrays. In packed array, I think you know these concepts from very long. Let me quickly revise this. Packed array represents continuous set of bits, contiguous. We generally call it as contiguous set of bits packed into a single address location. If I take this example, bit 3 down to 0b, all the 4 bits are stored in same address location. So these are the examples of packed array declaration. This is not possible. You're storing 6 integers into same address, which is not possible. Packed arrays support all SV operations. since they represent singular data variable. Since they represent only single data variable, it is possible to do all SV operations. You remember, right? In Verilog also, with vectors, you can do any operation, arithmetic operation, shift operation, everything you can do. For whom does the restrictions apply? Arrays, the restrictions apply, right? Same here. In unpacked array, memory is allocated for each element at separate address location. Like you see here, when I declare bit A 2 down to 0, is it packed or unpacked? So in this case, this array is unpacked array. What is the size of this array? 3. How many locations does it take to store A? 3 locations. Here, how many locations does it take? Only 1 location. You see here, A0, A1, A2 are stored in 3 different locations. Unpacked arrays does not support all system Verilog operations since they represent multiple address locations. Unpacked array represent multiple address locations, so you cannot use all SV system Verilog operators on that. Except for whole array operations, rest all can be performed only on the single index of the array. Only thing you can do is whole array operations. Tell me 2 whole array operations that we discussed so far. Compare and copy. If you remember yesterday, we did whole array compare, int A1 equal to int A2. That is whole array to whole array compare. And we did yesterday what else? Whole array copy. Except for that, anything else you have to do by single index only. What all operations does it support? Whole array operations. It can't be used in slices. You cannot use the slices. Arithmetic operations are not possible on the whole array. Let's understand through some example. First, let's talk about packed array operations. As I said, whatever operations we have discussed so far in Verilog and we'll discuss in system Verilog, all those operations can be performed on the packed array. Like if you ask me, can I do shift operation? Yes. Can I do bitwise operation? Yes. Can I do arithmetic operation? Yes. Can I do logical operation? Yes. Can I do concatenation? Yes. Means any type of operation can be performed on the packed array. Why? Packed array represents only one value. So if it is one value, you can do anything with that. Whereas when it comes to unpacked array, it represents multiple elements. It represents multiple elements. You cannot do a lot of operations because of that. Okay. And a lot of these concepts you know from Verilog, right? We have discussed in detail. So here, what all operations you can do, I just listed: bitwise, arithmetic, slices, whole vector operation, concatenation, shift, compare, equality, everything can be done. You know what is meant by bitwise operator, right? What does this will do? Bit by bit, it will do ANDing and assign it to bit array 3. Okay. Let's understand through this example. I have bit array 1, bit array 2, ANDed bit by bit for all 8 bits. So what, can you just go through it and tell me what will be the output? In this case, what is the, if I do bit 1 and with bit 2, bitwise AND, what is the output? What is the output? Zero, 1, 0 will come, 1, 0, 0 will come, 1, 1, 1 will come, and the remaining 4 zeros, and the last both are 1, so 1 will come. Got it, right? Okay. Like that, you can do addition, multiplication, all that is possible. You can even take the slices. What is meant by slices? You're taking 4 bits from bit array 2, 4 bits from bit array 3 and concatenating and putting into bit array 1. You can even do whole vector copy. So any questions in this? Okay. I am not running any examples in this because we have discussed these concepts in Verilog, right? When we discussed Verilog vector, the same concepts we dropped there. Some questions based on the packed array. Let's do this. Can you please do this question, first one? What should you do? Write logic to swap bytes in one line command. You have a bit 31 down to 0 data. I want you to write a code which will swap the uppermost byte will come to lowermost byte. Lower byte will go to upper byte. The one in the first position sits like byte 3, byte 2, byte 1, byte 0. Byte 0 will be what? 7 down to 0. Byte 2 will be what? Byte 1 will be what? 15 down to 8. Byte 3 will be what? 31 down to 24. Once you have done the swap, this should go here. Should come here. What else? This should go here. I want you to do it that in one line only. In one line, I want you to do that swap. Please do it. I'll give you a hint. You have to do swap concatenation. You have to do concatenation operation. Are you understanding the point? Someone has given you some number like this: 1, 2, 3, 4, 5, 6, 7, 8. Hexadecimal number. 32 tick H. How many hexa characters are there in this number? 8. After the swap is done, once the swap is done, what should happen is this number should come out as 7, 8, 5, 6, 3, 4, 1, 2. This is how I want. So your code should result in this. Please do it. Continue to work on that. Once you're done, please let me know. So how to do it? I'll explain. Okay. Data equal to some other data vector you take. Even you may take same thing, it will still work. See, lowest byte should come to the uppermost position. So data of what? 7 down to 0 will come to the most significant position. Lowest byte will come to the uppermost position, right? Then which one will come? 15 down to 8. Then 23 down to 16. 31 down to this. You understood this? Okay. Going by that logic, can you do write a logic to swap the nibbles here? So what is that I'm asking? Nibbles. Please do that. Earlier we did swapping of bytes. Now I want you to swap the nibbles. Please do that. Nibble means how many bits? 4 bits. So what I was explaining is, this is how you do the nibble level swapping. Next, we are talking about bit level swapping, lower bit going to upper position and vice versa. You can use a for loop. Let us also try using reverse method. Vector swap dot sv. module top, in module veg, 15 down to 0, vec initial begin end equal to 16 tick b 1111 0 0 0 1111 0 0 0. Now I'll just do vec 1 equal to vec dot reverse. I'm not sure whether that method will apply or not, but let's try it once. Dollar display 1 equal to percentage b. So now what are we doing? We are trying to swap on a bit by bit basis. There is no method by name. Reverse. Vectors don't have a method by name. Reverse. So hence we cannot use. So we have to go by for loop only. Can you write the for loop logic now? I want you to write the for loop to swap the bit level position.
हेलो। हाँ हाँ भैया, मैम आज आएगी मैम? अच्छा, मतलब नहीं 2 बजे खुलता ना क्लिनिक तो? अच्छा तो मतलब 5 बजे ही खुलेगा क्लिनिक क्या? नहीं मेडिसिन नहीं, मेडिसिन। अच्छा 5 बजे ना? ठीक ठीक ठीक।
Some of you are using put character, put C, get C. I don't know where put C, get C comes here. Is there a string here? We are done with string half an hour back. So there is no string data type. Then there is when there is no string, where does put C and get C come in? All you have to do is data of I equal to data of 31 minus I. Just one line, data of I equal to data of 31 minus I. That's all you have to do. Anyway, try this, please. Okay. And those who are not able to do, you have to practice these kind of examples. Means when you have got into this domain of training, verification domain, you have to start doing these examples a lot. You do it as a homework. Okay. It's very one line only. For loop, inside for loop, one line. That's all. Data of I equal to 31 minus I. Because 31 is the, you're swapping, right? 0th position should swap 31. So 0th position equal to data of 31. First position equal to data of 30. So how will you get 31 minus I? Next. Let's talk about unpacked array operations. Uh, it supports whole array operations. That is what it supports. Copy and compare. What is this? Whole array copy. Is it possible? It is possible, right? We have discussed whole array copy is possible. Whole array compare is possible. Is it possible? Arithmetic operations. Int array of 1 of 0, int array of 2 of 0, int array of 3 0. Is it possible? Yes. Arithmetic operations allowed when one specific index is selected. When you use a specific index, it's possible. Why? Because by using specific index, this becomes one value only, singular. This is singular. This is singular. Hence, it is possible. This is not possible. Because you are multiplying many elements with many elements and putting into many elements, which is not supported. Whole array arithmetic operation, not possible. By using only one index, it is possible. See, I can use only one index. Another thing is unpacked array can't be used in slices. Unpacked array cannot be used in slices like this. We cannot do. Elements can only be accessed as a single element. Even this one is not possible. You cannot use it in slices. I can do whole array copy int a equal to int b. So when I assign this one, can you tell me element basis copy like int a of what will be copied to int b of what? Can you write like that? There will be 4 such statements, right? You understand? Can you write that? You would have studied same thing in Verilog vectors also. Please try do this. 4 lines I want you to write.
बाबा मोबाइल दो ना इधर मोबाइल दो मोबाइल
Tell me what is the first one? You have 0 is equal to what? 5. The lowest position goes to lowest position. Next is what? 1, 2, 3. Here what? 4, 3, 2. The same way we did in Verilog. It's also same. Now let's talk about the next topic, that is multi-dimensional array. We'll just talk about that and yeah.
The array size is not matching, so can we compare and copy the array?
No, we cannot do. See, if the array size doesn't match, then copy compare is not possible. Array size is different. Copy and compare not possible. Give errors. We'll say that these two cannot be copied because their sizes doesn't match. You understood his question, right? In this case, both the sizes are same. Array size of 4, array size of 4. If it was different size, it won't be able to do this mapping. So hence it will give an error saying that you are trying to copy two arrays whose size don't match. Next, let's talk about multi-dimensional arrays. So this will be this. Multi-dimensional array. Let's take one simple analogy to understand what is multi-dimensional array. Okay, consider a bookshelf having 12 books. A bookshelf having 12 books. Each book having 4 pages, 14 pages. Each page having 10 lines. Each line has 9 words. So totally how many books? 12 books. Each book having 14 pages. Each page has 10 lines. Each line has 9 words. So totally in total, how many bookshelf has how many words? You have to multiply 12 books into 14 pages into 10 lines into 9 words. Those many words are there combinedly. So going by the same logic, through this we'll try to understand what is meant by multi-dimensional array. If we are declaring array, if we are declaring this bookshelf by addressing each page, means what? We are addressing each page, that is giving address to each page. Totally how many addresses will be required? Understand the point? If you are giving address to each page, how many addresses are required? Again, let me take one simple example. If this street has 40 houses, if each house is given one address, how many addresses will be required totally? 40. Let's say each house has 4 people. Each person is given address. So totally how many addresses will be required? 160. 40 into 4, right? Because 40 houses into 4. So depending upon how do we address, whether we address at a house level or a individual person level or a street level, you'll require different address. Let's say if I give address to only the street, how many address will be required? One address only, because you are not addressing house level. The same concept applies here also. If we are addressing each page, that is giving unique address to each page, the next page will have a different address. So totally how many addresses are required? 12 into 14. Why? 12 books are there, 14 pages are there each. So totally 168 unique address will be required. This is how the declaration will be. Please take a look. The word 9 down to 0, 8 down to 0. Page array. Because it's an array of pages. 11 down to 0 indicates what? The number of books. 13 down to 0 indicates what? Number of pages. You see, because you are giving address to each page, pages will come on the right hand side. That will become the unpacked array dimension. And each page has 10 lines, each line having 9 words. That will become the packed dimension. See, understand what becomes unpacked, what becomes packed. Basic data type is word only. Basic data type is word only. But because you are addressing at a page level, 12 books having 14 pages, each page having 10 words, 10 lines, each line having 9 words. This. Now do the same question. If we are addressing at book level, each book is given a unique address. First of all, have you all understood this one? ENG word means English word. Okay. It's the word we are taking. We still not talking about the system verlag here. We are just taking a simple analogy. Okay. Since we are addressing at page level, number of pages will become the unpacked dimension, array dimension. Whatever is the content of each page, lines and the words will become the packed dimension. Now, if we are addressing each book, each book will have one address. So totally bookshelf will have how many addresses totally? 12 addresses. Can you declare that? So how to declare it? Word becomes the base data type. 13 down to 0, 9 down to 0, 8 down to 0. See, 11 down to 0 will become the array dimension, unpacked array dimension. Because you want to give 12 addresses totally, right? See, if you are addressing at book level, totally shelf will have how many addresses? 12 addresses, 11 down to 0. Each book having 14 pages, each page having 10 lines, each line having 9 lines. So the order remains like this. First you take this, the first one, second, third, fourth. You understood, right? Next. Then it will be wrong. It's like shelf has the words, word has the books. Will it be correct? No, right? You cannot understand like that, right? Does English word has a line? Right. Lines has the words. So that order only has to be followed compulsory. You cannot interchange this. Can you write this one? If you are addressing each word is given an address. Each word is given a unique address. So totally how many addresses will be required? whatever that multiplication, right? 12 into 14 into 10 into 9. Each word has an address. Like I said, we took an example of a 10 houses, each house having 4 people. So all people needs address. So you need to multiply 10 into 4. Here what you have to do, can you please do that? Please declare this. You understood my question, right? I want you to declare the same bookshelf where each word is given a address.
अरे बहनचोद, राजपाल यादव चोद ना।
So how this will be? Word array. See, earlier we declared as book array, page array. Word array, 11 down to 0, 13 down to 0, 9 down to 0, 8 down to 0. If you have done anything else other than that, it's wrong. Anything else other than that you have done, it's wrong. It's wrong means your understanding is wrong. You are not able to understand the concept of multidimensional arrays. You have to sit afterwards and try to understand the concept. See, I've taken a simplest possible way of explanation, books, pages, all that. You have to try in that manner only. If you are addressing each bookshelf with one address, okay, entire bookshelf. If we addressing entire bookshelf with one address, total address is what? 1. So entire dimension will come on the left hand side because whole shelf has only one address. So accordingly you have to ask. Let's say if someone asks you to declare an array, you have to ask at what level we are giving the addressing. Okay. So the requirement will indicate how the addressing should be done. There are, you see, in the same bookshelf, there were 5 different ways, 5 possible declaration. The requirement will tell which one to use. Now, if you take the 7th book from the shelf, how many total words are there? Bookshelf 7th, if you take bookshelf 7th, anywhere, let's say I take 7th bookshelf. So totally how many words will be there? 14 into 10 into 9. 14 into 10 into 9 words will be there. Each book will have those many words. 7th book, in that you have taken the 9th page. How many words will be there in that? You have to multiply the remaining dimensions. What is that you have to multiply? 10 into 9, that is 90 words. What if I take bookshelf 1, 2, 3, 4? How many words does it represent? Bookshelf, see this is the bookshelf, where somewhere I declared, wherever, doesn't matter actually. 1, 2, 3, 4. How many words does this represent? Tell me, think over it and tell me again. 1. It only represents one word only. Why? Bookshelf 1 means you are taking the first book. 2 means what? In the first book, second page. 3 is what? Third line. 4 is what? Fourth word. You have taken first book out of the shelf. In that first book, you went to the second page. In the second page, you went to the third line. In the third line, you went to the fourth word. Now, going by the same analogy, what does it represent? Tell me. How many words does it represent? How many words does it represent totally? 9 words, right? You understand? 9 words it represents because you have taken the first book from the shelf, 7th page, 8th line. So each line has what? 9 words. So it represents totally 9 words. How many words does it represent? 90 words, right? Because it represents one page. Each page has 10 lines into 9. That is 90 words. Now, do you understand how to work with the multi-dimensional array like bookshelf? So first you always have to start with the book only. You cannot start with a word. First you have to select a book. In that you have to select a page. In that select line. In that select the word. You cannot do the reverse. The same thing I have explained here. I think we have discussed the same concept. Now replace word with bit. Replace English word with the bit in above bookshelf example. Then it becomes the SV multi-dimensional. Wherever we used English word, instead of that use what? Bit. Just replace this word with what? Bit. Then it becomes system Verilog multi-dimensional array. Can I use int here? Why I cannot use? Int packed array is not possible. Int packed array is not possible. Hence you cannot use. But bit is possible. Bit reg logic is possible. Same thing I have explained. How many dimensions are there here totally? It's a 4-dimensional array. 4 dimensions, hence it's a multi-dimensional array. It represents totally how many bits? 8 into 7 into 8 into 10. 8 is this one, 7, 8, 10. Totally how many addresses are used to save this? Totally how many addresses are saved? You have to multiply these 2 dimensions. The one on the right hand side you have to multiply because whatever is on the right hand side, it represents the number of locations. Whatever is on the left hand side represents number of bits in each location. Understand? One on the right hand side represents the number of addresses. One on the left hand side represents the each location, how many bits are stored. In this case, how many addresses does it array use? 56 addresses. Do you agree? Array uses, this array requires 8 into 7, that is 56 address locations. Each location storing 8 into 10, that is 80 bits. In total represents 8 into 7 into 8 into 10 bits. You got it, right? Then, if I give multi-array equal to 6458 equal $random, so how many bits will take the value? Only 1 bit will take the value because 6th element here, 6th index here. That's how coloring I have done. 6th here, 4th here, 5th here, 8th. So it will only represent 1 bit. So multi-array of 6 represents 7 into 8 into 10 bits. Multi-array of 6 down to 4 represents 80 bits. Multi-array of 6, 4, 5 represents 10 bits. 6, 4, 5, 8 represents single bit. That is the LSB bit of $random gets assigned. So let us stop here. Okay. In the next session, we'll talk a little more deep into multidimensional arrays and then we'll move on to the other topics. So please try to practice these examples. Okay. Any questions before we end?
This conference is no longer being recorded.
Is this topic happening in the labs or what is happening in the labs right now? Second assignment. It is with arrays and other things? Okay, fine. We'll end this session.